In this video, we're going to take a look at some more examples of writing the equation for a hyperbola in standard form. We're just going to pick up from where we left off in the last video. So, all right, we have x squared plus 20x minus y squared plus 10y plus 39 equals 0. So let's subtract 39 from both sides to get the variables on one side. Now we're going to find the vertex of x squared plus 20x. That vertex is at negative 10 and negative 100. Now the vertex for negative y squared plus 10y, which again we're going to keep this consistency here, we're going to find the vertex of negative x squared plus 10x. So the vertex of negative x squared plus 10x is at 525. So we're going to have x minus a negative 10, which will become x plus 10 in parentheses squared. And we're going to have a y minus 5 in parentheses squared. So we're going to have an x plus 10 in parentheses squared, and we're going to have a y minus 5 in parentheses squared. Now let's bring down the coefficients for x squared and y squared. So here we have a coefficient of 1 for x squared, so we can just keep a 1 there or not write anything in front of the x. But the y squared has a negative coefficient, so the in front of the y minus 5 squared, we need to put that negative coefficient of negative 1, or just a minus symbol. Now we are going to bring down the negative 39. This time our y is the one with the negative in front of the squared term. So we're going to be subtracting the absolute value of 25 from the right-hand side. So we're going to subtract the absolute value of 25 from the right-hand side. And because the x squared has a positive in front of it, we're going to add the absolute value of negative 100. So when we simplify the right-hand side, we get 36. So we have x plus 10 in parentheses squared minus y minus 5 in parentheses squared equals 36. And to get this thing equal to 1, just divide both sides by 36. So we have x plus 10 in parentheses squared over 36 minus y minus 5 in parentheses squared over 36 equals 1. So, and yes, it is perfectly allowable for a squared and b squared to be the same number. Moving on to example 2, part D, we have x squared plus 18x minus y squared minus 20y minus 188 equals 0. So we're going to start by getting the negative 188 to the right-hand side by adding it. And for x squared plus 18x, we're going to find the vertex to be negative 9, negative 81. And for negative y squared minus 20y, I'm going to advise you that you find the vertex for negative x squared minus 20x, which that vertex is at negative 10, positive 100. So we're going to have x minus a negative 9 in parentheses squared, which will become x plus 9. And then y minus a negative 10 in parentheses squared will become y plus 10. So there's our x plus 9 in parentheses squared. There's our y plus 10 in parentheses squared. The coefficient for x squared is 1, so we'll copy that down in front of the x plus 9. And then the coefficient for y squared is negative 1, so we'll put that negative 1 in front of y plus 10 in parentheses squared. And then bring down the 188. And then since the y squared has a negative in front of it, we're going to be subtracting the absolute value of 100, which is 100. But we're going to be subtracting this y coordinate for this vertex because of the negative in front of the y squared. So we'll have 188 plus the absolute value of negative 1 plus the absolute value of 100, and that gives us 169. So dividing both sides by 169, we have x plus 9 in parentheses squared over 169 minus y plus 10 in parentheses squared over 169 equals 1. And there is our standard form. All right, that about does it for this video. Thanks for watching. I'll see you next time.